Hi, a viewer called Stephen asked would I be to have a look at his digital photo frame. So this is made by Sony, and what Stephen said was when he had the photo frame on, the display progressively got dimmer and dimmer and dimmer until he could no longer see it. It does have a HDMI output, which I think is underneath one of these flaps here. That's for SD cards and things. Let's have a look at this one. And he said if you connect it to the HDMI, you do get a picture on the TV. So the actual logic part seems to be working. It seems to be a problem with the actual display itself. So let's just see what it's doing. So this is the power supply here, which was a replacement one. So I'm just going to plug this in. And the output is 8.4 volts. So let's just check that we are getting 8.4 volts. And we are. Right, let's plug this in and we'll switch it on. And I've just seen something very faint on the screen. Let's try that again. I couldn't see it in real life, but I could see it on the camera there. It looked like frame or something came up in the middle of it. Yeah, I'm sure I can see something in the middle of the screen there. Just going to try that again. Yeah, there. S frame. So I think it's a problem with the backlight on this, or the backlight circuit. Right, I've seen what it's doing. Let's see how it comes apart. So I see we've got maybe 5 screws. So I can see 2 there, 2 there, and 1 here. I'm not sure if we've got to remove that one as well, but we'll give it a go. So I'm going to fit the actual cold cathode fluorescent tube that's gone in the actual display itself, or if it's a problem with the driver circuit. Like the transformer's gone open circuit or something. I don't know if that's like a little flap for a backup battery or something. It's just nearly fell inside. So I'm not sure what that's for, but I don't think you need to take it off. I'll just flip this around so I can get to the other screws here. And I'm just going to have to get a spudging tool. Let's just try a couple of these. Right. Open it this way then. So we've got a little ribbon cable here. I'm just going to spin this around. This looks like the backlight driver here. I'm just going to move those little screws and that just a bit out of the way here. Right, let's zoom down a bit. Let's see if we can see this backlight driver doing anything. So it looks like it's fed from this ribbon cable here. I guess that must be the output wire here. Let's undo these 2 screws. Let's just have a little bit visual inspection of it first. Actually, looks like you need to remove this little bit of plastic. That seems to be holding it in as well. I guess that's for the LED. Let's get that bit out of the way. Right, I'm just going to disconnect this a sec. And let's have a quick look over this board, see if we can see anything. Looks like we've got a couple of MOSFETs there. And I guess that must be the driver IC. And we've got a 0 ohm resistor there. So because this was a progressive failure, I'm just wondering whether it could be the actual cold cathode fluorescent tube itself. Because if, let's say, the 0 ohm resistor failed, it would just have gone off instantly. Whereas he said it sort of got duller over time. I mean, it could be a possibility that there's a fault on this transformer here. Which we couldn't measure the resistance of. So I think I'll pull the data sheet up for this chip and then we'll check some voltages. So I've pulled the data sheet up for the BD9882 and pin 20 here is the supply coming into it, and pin 7, which is this pin here, is ground. So let's just see if we get continuity between, say, ground here and pin 7. Yep. Let's see if it goes to this capacitor. Yeah. And let's see if the other side of that cap goes to pin 20. And it does. So I think I'll power it on and we'll measure the voltage across this capacitor here. Is that? No, I was just seeing if that capacitor was shorted there, and it's not. So let's see what voltage we get on this capacitor. I'll just zoom out a bit so I can get the meter in shot. I'm just going to volts DC. I'm just going to plug the power in. And it's switched off at the moment with this switch here. So let's see if I can get on that capacitor there. Like that, and then switch this on. Now it might take a moment for it to switch the backlight on. Oh, there we go. And we've only got a 1.9 volts there. And according to the specifications on the chip, we're supposed to have between 5 volts and 14 volts. I'll just bring that up so you can have a look. We've only got 1.9 volts there. I'll just switch this off. So why have we only got 1.9 volts? So I wonder if the fault is further back here somewhere. I'll just unplug this a sec. Let's see if we can get this part off. Let's see if we can trace where this ribbon cable goes. I don't know if that's going to move or not. So that's the main power in. I don't know if I've got to remove these screws. It's very windy outside again, as you probably really hear. Right, so I'm just going to unplug this little display connector here. I'll try to. Let's just zoom down a bit, see if we can see anything. A few power supplies around here. So I'm either suspecting there's a short on this board here maybe, or whatever supplies this board with the power. There's no real electrolytic capacitors or anything I can see on here, apart from that one. I wonder if we can figure out where the supply comes in here. Then we could disconnect this board and see if we get the correct voltage. Let's just see if we can figure out which pins are what. Well, the ground, it doesn't matter, it's really the supply that we need. So let's see. Let's go into continuity again. It doesn't appear to be on that side. It's a bit awkward, this. Let's see if I can unplug that. Make it a bit easier if I can get that out of the way. Well, I don't seem to have continuity with anything there. I wonder if it's something on this board then. I mean, there's a big cap there, so that might be where the supply comes in. Let's just check that 0 ohm resistor. Well, that's okay. Doesn't appear to be the supply. I'll just try and hold this on and go to the other side of the board. So it goes to there. So we've got a 1K resistor. Let's see what that measures. Ah, let's just zoom out a bit and I'll get the meter in shot. So we've got a 1K resistor there. If I just touch my probes together and then go to that side of the resistor. We're not getting anything. So that resistor's failed. Right, I'm going to bring the microscope in and then I'll show you this resistor measured again under the microscope and then we'll change it. Right, got the microscope set up. So this is the resistor here. If we measure it, if I go into ohms, open circuit. Now, has something failed and caused that to go? Because it looks like that feeds these two MOSFETs here. And I've just checked what these are, and they're dual MOSFETs. So what we've got, I think that's source, gate, and then drain 1 and drain 2. So these are, they've got a P channel MOSFET and an N channel MOSFET in. And I think they've used 2 of them because one will be positive and one will be switched negative, and then they'll swap around to make an AC waveform to drive this transformer here. So I'm just going to spin this board around a little bit and let's just see if we've got any shorts on this MOSFET. Well, that one seems to measure okay. We'll just try from the gate. It's okay, let's try. Ah. Let's try this one. So it looks like this MOSFET here Looks like this one's failed. Or have I just triggered it with my probe? Let's just try. Right, I think we'll need to desolder these and then test them out of circuit to find out whether one or both of them has gone. So I think I might use some low melt solder on this just to make those easier to remove. Let's see if it's using the hot air and blowing components around. So I'm just going to get my soldering iron and some low melt solder. Right, I'm just going to add a little bit of flux first. Right, I've got some low melt solder here. So I like low melt solder. Right, that's the 2 chips off. Just move the board out of the way a bit. Right, let's try that again then. I don't seem to be getting any short now. Let's try shorting these leads around. Don't seem to be getting any readings at all on these. Let's check my probes. I'm getting a reading there. Those might actually be alright. Let's just check these diodes. They seem okay. So I wonder if I just triggered that with the test probe and turned that MOSFET on. Might well be the case. Well, I think we'll fit those again and then we'll replace this resistor and we'll see what happens. Right, I've quickly replaced those 2 MOSFETs. So now we need to change this resistor out. So at first I got this one, but it's too small. And then I've got this one off an old board, which appears to be the same size. Even though it looks bigger, I think it's because this one's got like more solder around it, so it actually looks bigger. Now where did that go? There it is, great. It just shot off there. Right, so let's see if we can get this one off. I'll just try, I'm trying to think the best angle to try and get this off now. Just going to add a bit of fresh solder to this first. So really get some of those hot tweezers. I've had a couple of companies actually wanting to send me some, but I'm just never bothered. I'm just going to angle this board around a little bit. I'm just going to add a little bit of fresh solder on here. Right, let's check this with the meter now. Just going to do ohms. Yep, that's better. And I did check across these MOSFETs, I just want a diode check. And we don't have a short. So I think I've triggered the gate when I've been testing it. So, right, I think we'll put this back in and we'll see what it's doing now. Right, I've just screwed this cover back on. Need to plug this in. I need to plug the little circuit board in here. I need to plug the backlight in. I'm just going to put one screw in there just to hold it. Right, let's plug some power in. Let's just flip it over a bit and let's see if it does anything now. We still haven't got any picture. Let's switch that back off a second. Let's get the test meter back out. I'll just zoom out a fraction. Right, let's see what voltage we get on this side of this resistor. So I'll just find a grounded point. Switch it on. And we have got, ooh. Right, so we've got 8 volts there. And then it does switch something on. And I'd hear like a click or something here. I'm just going to unplug this backlight. I wonder if it could be the transformer. It's dropping down to 3 volts, that. So, we've definitely got something going on there. I wonder if the thermal camera will show anything up. Let's go and grab the thermal camera. Right, back with the thermal camera. I'm just going to move this forward slightly. Let's just switch this on. It doesn't appear that there's anything getting hot on this side of the board. Apart from the resistor there's starting to get a little bit warm. Let's check the chip on the other side. Let's unscrew this again. I'm definitely not happy about something. Right, let's switch this on now. Just give it a moment. That's not really showing anything up either. Well, there's definitely something drawn voltage there because it's pulling the voltage down. Or drawn current rather, so I'm not too sure what to check next. I thought I'd get it under the microscope again so I can check some capacitors and things just for shorts. That one's okay. That one's okay. There's a little one there. That seems okay. Let's just flip the board over. Well, I'm kind of suspecting this IC, and the reason is the MOSFETs seems to measure okay, and the fact that it's drawn excessive current, the only other thing really on the circuit is that IC. So that's what I think the problem is. I mean, I could connect it up with the bench power supply, and we could try injecting 8 volts, because that's what the power supply is supposed to be. I can try 5, and we'll just see if this IC gets hot. So I think that's what I'm going to try next. Right, I'll tag a couple of wires on here first, and then I'll hook the bench power supply up. Right, got the bench power supply hooked up, and I've got the meter hooked up with the bench power supply as well. I've got the thermal camera here. So I'm just going to switch that on, and I've got the bench power supply set to 5 volts at 200 milliamp. So let's see if we get anything hot. It doesn't appear to be. I think the wires just came off. Let's put this wire back on. Right, let's try that again. It's not actually drawing any current. Oh, that's a bit weird. Why is that? I had another look at the data sheet, and pin 11 here, which I've just soldered this wire to, it actually goes to this resistor here, is actually the enable pin for this chip. So that needs to be tied to the supply voltage to get the chip to operate. So I've connected that up, so I'll get the microscope out of the way and then we'll try that again. Right, let's try that again. I've got it set to 5 volts at 20 milliamps. Well, I heard it actually spring into life there. It actually drew 50 milliamps and now it's drawn 1 milliamp. So it did that for a little while and then shut down. And I could hear my bench power supply sort of kind of oscillating there. So I might get the scope hooked up to this. We'll just see if we get any waveform on the output. Right, I've got the scope hooked up. So I'm just going to go on the gate pins on these MOSFETs while I'm applying power. Let's just try this pin here. I'm just going to apply power now. Yeah, I've got a waveform there. Let's try this gate pin. Yeah. Let's try this one. Yeah. I'll try this one. So all of those seem to be working. Let's just see what we're getting on the transformer. Yeah. So we're getting switching to the transformer. We should try it on that side. Let's try that again. Yeah. So I would say this is working, but why is it not working in the device? So I've hooked it back up to the cold cathode tube that's at the LCD display. I'll just show you what I've discovered. So I'll turn the light off so we can see a bit better. And I've turned the power supply up to 8 volts at 1 amp. So are you ready? Right, I'll put the light back on. So I think the fluorescent tube has failed in this and it's causing a partial short and it's taking that resistor out. So I'd say the driver's working, but I'm not 100% because I haven't got another driver to try, but I'm fairly sure it's the fluorescent tube. I'm going to have a hunt about, see if I can find an old LCD display that's got a fluorescent tube in and we'll just see if it works on that tube. Found a CCFL panel off a little LCD display here. This one goes all the way around the edge. It actually goes across the top, down the side and then back, so it's sort of 3 tubes in series. So I've hooked it up, but when I switch it on, it kind of goes a bit berserk and doesn't light up. That's 8 volts at half an amp, I've got it as well, and it just doesn't like it. So it got me thinking, there's a capacitor here on the output, and I wonder if that could be breaking down with the high voltage. Well, saying that, it doesn't seem to be when I disconnect the output. Because I was just thinking about changing that capacitor, but then it would be shorting out all the time, and when I haven't got the tube connected, it doesn't appear to do this. It appears to be okay. So it might just not be compatible with this kind of tube or something, I don't know. So I thought I'd just try one of the tubes. I thought, oh, I'll just disconnect it there where it's joined. And what I've discovered is it's not joined. It's actually just one tube and it's actually curved round the corners. I've never seen anything like that before. It's a bit weird, isn't it? So I just thought I'd try something else. I thought I'd just try swapping the wires around in case there's some kind of polarity thing. But I wouldn't have thought so because it's AC coming out and there's no rectifier diodes. But I thought, well, I'll just swap the wires just in case. Just in case I had any bearing on it. And it does actually light up for a moment now. So I'm fairly sure that the driver's working and the fault's actually the tube on the LCD. So whether or not we'll be able to repair this or not's another thing. So I'm going to tear into the LCD now and we'll see how far we get. Let's move some of this stuff along a little bit. I think I'll try and remove this whole part first, the metal casing part. Let's try and get past this bit here. Because that should just go through when we get the front bezel off. I mean, we might be able to get a whole LCD display for it if we can't get the actual fluorescent tube. I don't think this part's going to lift off, is it? Because it's screwed through here, isn't it? And through there. I'm going to have to take this whole thing off. It's like a million screws. It's going to be a nightmare, this. Unless I can just slide the bezels off, maybe. No, I'll just put that screw back a sec. Let's just try undoing these corner bezels. So we'll lift these catches up. And it looks like one of them's underneath this metal thing here. Might be able to get that. Oh, that's one off. That's the bottom one off. I think he just wants to keep this for sentimental reasons rather than anything else. Right, that's the bezels off. I don't know how we'll get this plastic off. What's holding that on? Is it glued? Yeah, I think that's glued. I don't want to put any IP on it because IP and LCDs don't tend to work very well together, as I found out when I had a look at that Facebook contraption thing. Well, we're making slow progress. Got the display bit off. Just put that to one side. Let's see if we can get this LCD out now. Which feels like it's maybe glued in as well. There is a couple of screws here. Just wonder if those have got anything to do with it. I think they may have. Right, is there any more of those screws? Because it still doesn't feel like it wants to release. Right, we're held by the cable. So let's see if I can disconnect that. That's the cable disconnected. Oh, there's another screw. Don't believe it. Right underneath the middle here. So you have got to take all this off. What a nightmare. I thought there was a little bit of a shortcut there, but I guess not. Nice. That's the brains of the unit. Let's take this little ribbon cable off as well. Just get that out of the way. Yeah, there's the other screw. A little earth strap thing here. Right, so the LCD is out. So it is a CLAA 102 NA32CW. And that's where the backlight tube goes in. Well, the display is broke anyway, so I suppose if we break it any further, it doesn't really matter, does it? Try and get this bezel off. Is the board stuck down? It looks like it is. I was hoping to try and get this board lifted up. Well, it looks like it's glued down. I'm worried about these cables here. Unless we can pop the LCD out. I'll do this with the TV once to repair the backlight, which was an LED TV. And remember, it was a nightmare. So I think the chances of repairing this are probably quite low. But we'll have a look. I'll try and get something in between this to try and get this bit of plastic out. Ah, there we go. It's funny that this one's curved as well. But we can see the problem now. I'll see if I can get this tube out completely. just zoom down a bit. There we go. And we'll see just here how it's all burnt. And if we go to this end, it's a bit hard to see with the black background, but it's all burnt at that corner there as well. Yeah, so that's what's wrong with this. This tube has failed. I've only got a limited life, so it needs a new tube. And because it's not a straightforward tube, it's bent at an angle there. I doubt we'll be able to get anything like that. So I'll see if there's a display available, and if not, then I don't think we're going to be able to fix this one. Well, I've had a look online to see if I could find this display, and I found it on a site called Panel Look, which gives the description of the resolution and what connector it uses, how many bits it is, and things like that. Now, unfortunately, this display is obsolete. Now, I did manage to find a suitable replacement on AliExpress. However, the price of it's £35 plus tax, which is about £7, so it works out around about £42 for a replacement screen. And you can buy a full working photo frame, albeit slightly smaller, on eBay from anywhere from £10 up to about £25. So to me, it doesn't seem economical to repair this. So I've emailed Stephen just to see what he wants to do. But to be quite honest with you, I don't think it's worth doing anything else with this one. So I had pretty much given up on this, apart from if we could get a new display. But I had a sleep on it, so this is the next day, and I thought, I'm sure I've got some old Android tablets kicking about somewhere. So I managed to dig them out, and I took the LCD screens apart. But these had an LED backlight in. So I thought, well, why don't we just put an LED backlight in it instead? So what I've done, I've put the LCD screen back together. I managed to wire an LED backlight into it. And what I've got down here is just a bit heat shrink with two 100 ohm resistors in parallel. And that just links to the 8 volts there. I did visit a site for an LED calculator, because when I run it on the bench power supply, I needed about 50 milliamps for it to light up at a nice brightness. But when I used 300 ohms, it was a bit too dark, so then I reduced it down to 200 ohms and then ended up with about 50 ohms, which is like an okay brightness. So we'll plug it in, we'll see what it's doing now. I'll just get the power adapter. We'll switch it on. And I'll just turn the light off. So there we go. So I mean, it is working. It's still not particularly bright. Well, what I'll do, I'll get an SD card with a couple of photos on, and we'll see what it's like displaying photos. Well, I got an SD card, but then I found out that there's actually pictures built into the internal memory. However, they were not displaying that great because the brightness wasn't bright enough. So I've swapped out my 300 ohm resistors, which would give about 33 ohms, for two 47 ohm resistors in parallel, which give about 25 ohms, and the brightness is a lot better now. So I'm just going to put the heat shrink back on, and then we'll just give it a test. Well, I've downloaded some pictures off the internet. Just, I don't think Stephen would have been best pleased if I was showing his pictures on the YouTube channel. So this is it working. I'll just cycle through a couple of more pictures there. So I mean, I don't think it's actually too bad. It's actually came out better than I thought, to be quite honest with you. I still think it's maybe a slight on the dark side, the brightness, but it all seems to be working. And you can get the clock mode back up as well. I'll just get that on, 2 seconds. And that's it, running its clock mode there. Now the only downside is not being able to control the brightness. So it's going to be fixed at this brightness pretty much all of the time, in the daytime and the night time. I'm not sure whether it sort of automatically dimmed or not. But at least it's working. Right then, if you enjoyed this video, give it the thumbs up. If you want to see more like it, please subscribe. Any comments or questions, please leave it in the comment section below. And as always, have a great day. Thanks for watching.